Madan started working on multi-ring raft implementation, and he'll provide more details on that. And this is to enable more work in cardinal release. So overall, the problems that were solved is we're starting to address levels of power to enable us to demonstrate increased throughput as numbers of ONOS instances are going up, and also to reduce the amount of locking in intent store. And also there was a large amount of technical debt cleaned up. Things that sort of hit our sprint hard this time around. It was actually, even though it was a 2-week sprint, it really almost felt like a 1-week sprint because of various meetings, such as the Intent Summit, a number of meetings with partners and potential partners, which ended up gobbling up half a day at a time. So with that, I'm going to let Ali and others cover the individual areas.
Okay, thank you. So now there's Ali on for the southbound.
All right, so for the southbound, if you get closer to... So hi everyone, for the southbound we've implemented null providers. These providers are kind of like zero resistance southbound. They're mostly targeted at helping us do some performance testing. So we've implemented a device, host, link, and flow and packet null provider, and they're configurable. So if you want to see how they can be used, either send me an email or ask a question on the mailing list, and we'll help you out there. So the topology subsystem has been refactored to not recompute a whole topology for every event and avoid pre-computing paths ahead of time, which turns out that these are paths we don't end up using anyway, so they were computed for no reason. And we've introduced a driver subsystem. This mechanism would allow you to introduce a scheme for abstracting device-specific behaviors into the core and help you treat them into any part of the ONOS and allow you to introduce device-specific behaviors in your implementations. So that's for the southbound.
Okay, thank you. Oh, maybe you want to...
oh, that, yeah.
Yeah.
That one.
Oh.
So I've also been working on the flow subsystem design. So the idea here is, previously in ONOS, we had this kind of crazy mechanism where any person using the flow subsystem would essentially, for lack of a better metaphor, drill a hole through the system to the ground and monitor what was happening on, like basically get futures that would allow him to monitor whether the work was actually processed and arrived to the switch. This caused a lot of churn in the system. So a lot of churn and also a lot of performance, had a lot of negative performance impacts. So the idea here is any application using the flow subsystem calls an ASIC API. As soon as he submits a piece of work, the flow subsystem says thank you and returns the call to him. And the idea here is you take a batch, and our notion of batch has been slightly expanded, but I don't think I'll get into it. Takes a batch, splits it up on per device sub-batches, and for each of these sub-batches spawns a different worker thread, which will either do the work locally, depending on who holds the mastership for that device, or send that batch east or west to the neighbor, who will then do the work and notify the peer who calls him about the work being done. This introduces a much greater level of parallelism and allows us to have explicit callbacks when things are done, rather than having the application monitor for whether work is done. It's a much crisper interface and also leads to much simpler code, which is a great thing.
Yeah. Can I add one thing, Ali? Also, as part of this interface change, we've introduced the notion of staging.
Yeah, I kind of, yeah. So within a, well, I'll get to your question in a second. So within a batch, there are stages. These stages are explicit orderings of things that have to happen. So only one stage is processed at any given time, and they're processed in order. All right. So that kind of gives you a better handle. So like the intent system can actually spell out what order it would like these batches to be processed. It's better. Yes, it leads to a higher level of parallelism. Higher level parallelism, and also where a higher level parallelism, and also we don't waste resources just waiting on something. Here we don't actually. Well, there's only one place where we actually wait because we gotta wait somewhere. But that's the only. It's basically when we distribute the work to the peer, we have to wait for the response to come back, and that's the only place where we wait. Other than that, it's completely parallel. Of course, I mean completely parallel. If all your devices are connected to the same ONOS instance, then yeah, it's parallel until you get to the egress point where things have to go out the same pipe. Right? So that. Is there what's next?
So that's only the design phase, right? The design is not.
No, it's nearly finished.
The implementation is finished.
Nearly finished. Yeah. I'm having just problems adapting the tests we had with this because now it's an async API. So when the test make calls to the API, the call is returned, the test proceeds, but the work hasn't been done yet. So it's just annoying, and we need to find a better way of doing our tests, which is this in the way.
All right, thank you, Ali. So since we are going bottom up, let's go from the southbound. We move to the core, and we have Madan online that will give us an update on the work done on the distributed core.
Can you guys hear me?
Yeah.
Okay. So just wanted to give an update on the work that we did in this field. There were two tracks. So one was Jono worked on redesigning the intent store, sort of the backing store as a eventually consistent store that uses techniques similar to what we used in the topology subsystem. Like full replication and gossip-based anti-entropy and so on. So this is mostly work that Jono did in this sprint. So we started out sort of building out another instance of a gossip intent store, and we made quite a bit of progress. Wrote a lot of code, but we realized that what we needed was a sort of a reusable and a simpler abstraction for a eventually consistent map, which we can in turn use to build this intent store. And sort of midway through the sprint, we went ahead and built this eventually consistent map interface and the implementation for that. So what you now get is basically anyone can create like a map that does all the replication and reconciliation and synchronization for you, and all you need is like basically one line to create that map. So this is something that we are using in the new intent store, and also the idea is that any application developer or any other subsystem that needs to manage state will be able to use this. Sorry, it's my daughter.
Madan, she's not agreeing with your statement, I think. Are you sure that's what you want to do?
Yeah, I think he has a comment here. So yeah, and so this is what we are using in the new intent store. So the piece that is coming next is the persistent support. So right now, what this implementation does is basically store all the data in memory, similar to what we do in the gossip device store and link stores. So with persistent support, that would sort of complete this. And also again, for anyone using this, that would be an optional feature that they can include when they create this map. So that's the idea. If you just want to go with in-memory replication, that's fine. But if you want persistence, that's a feature that you can request when you create an instance of this map.
This is really neat. So, but tell me, so are you seeing significant performance improvement from going from strongly consistent to eventually consistent and all that? I mean, this is too early to.
So I would say this is in the early stages. We haven't done any end-to-end performance measurements. Again, I would just knowing how both of these systems work, you would expect better performance in this approach than in a strongly consistent approach. But we haven't done any end-to-end numbers to sort of comment on that at this point.
Okay. And this is not into the system again, or this is still under development? Maybe you said and I missed it.
Well, parts are in development. A lot of it has been checked in already. So if anyone else wants to play with it, that is available for them to do so. Can we go to the next slide, Luca?
Sure.
So the second track was the work that we did to basically towards building a partitioned consistent data store on top of Raft. In the first release, we had a version of it which was basically running a single Raft cluster to do state management. That particular version was hasn't matured in time for our release. So while we spent some time developing it and also running some tests, we were not satisfied with the overall stability level of that. And also we were well aware of the fact that that solution would have some limitations in terms of its ability to scale to larger clusters. Even if you add more nodes with a single consensus ring, you would essentially sort of submit the command to the same set of nodes, and you'll have to coordinate. So what we did in this sprint is essentially that will help us understand, basically surface all the important challenges in doing so, and also see if we can essentially build a prototype that does the multi-instance Raft and see how that works. So what we did in this sprint is essentially implemented this prototype. We were able to sort of run multiple Raft instances in a single JVM. Again, this is what we will need when we go towards this partitioned approach. Another important thing is that we also have a persistent log, which is recording all these updates that are submitted to the cluster. This is also an improvement over what we have in the first release, where we were using Hazelcast for some of this kind of state management, and Hazelcast doesn't give us persistence. So this is also an improvement over what we will have in the first release. Again, this is the prototype has been tested under various simulated failure scenarios. You take down the cluster completely and bring it back up, make sure all the data is still there. You do things like take down a node, completely wipe out the disk and bring it back, and see how it recovers the data from other nodes in the cluster. So these were all the different failure scenarios that we tested it, and things seem to work. So the next steps in this are essentially integrating this into ONOS core. Right now, what we have is the messaging layer in this Raft cluster is a very simple Netty-based framework. Like for example, we want to use the cluster messaging that we already have in ONOS to also do the messaging for this cluster. That sort of simplifies the messaging concerns to one area. And also, again, overall testing and performance measurements and so on. So there's work to be done, but a lot of progress has been made in this sprint.
Okay, sounds good. Thank you, Madan. Okay, so let's move to the Northbound with Brian.
Hi guys. So there's three major places we made improvements to the northbound this iteration. The first was the flow rule API that Ali sort of alluded to and Thomas talked about a bit. But the idea there was the API changed a little bit, and then the implementation changed a lot. With the intent subsystem, we took a look at the API again and realized that it was sort of needlessly complex, and app developers sort of misunderstood things, probably because the semantics were too complex. So we actually were able to simplify the API down to 2 calls. Basically, submit and withdraw. Those are the calls that will actually result in action. This will enable us to do batching in the manager for performance, where we can reason more about optimizing across applications. So change the semantics a bit of the API by introducing this notion of a key, so that your policy can have a key, and that policy will be versioned. This is sort of in line with the store enhancements that Don talked about as well. So new store should help improve performance. New API semantics will enable us to implement next sprint more parallelism in the intent framework and remove the serialization that currently happens based on app ID. Finally, we introduced a completely new northbound API and subsystem. This is an API for registering applications. And so the idea is that an application can be registered to one instance on the cluster. It's a more fully blown concept of an app than we currently have. Instead of just an ID, it also has name, attributes, versions, URIs to features, repositories. So this will make it easier to deploy software in the distributed cluster. It'll also bootstrap the security work that we wanted to do around permissions and application authentication that hopefully the SRI guys will be able to do. So one picture that we wanted to show was this is the new design for the intent subsystem. The API at the top has been simplified, as I said, to submit and withdraw. And we've got a process in place that will hopefully enable the system to do batching when possible. The idea is that the store will be responsible for delegating intents to the instance that will become the master for their installation. The master will take over the process of compilation and installation, and then updates will be written to the state in the distributed store and passed on as events when appropriate. So this work is just slideware now. The API changes have gone in, but the implementation will hopefully be accomplished next spring.
That's good. Thanks a lot. Okay, so let's now move to Subin with test.
Some demos done on my computer.
Oh, okay. Okay, hold on just a second. We'll move the. Do you want to use the slide before?
Just use. I use the same slide, but you just have to give me the. I can make the presenter.
Ah, perfect. Yeah. Well, if you want, I can do it from here. Subin, done. Okay. Okay.
Second. I lost my slides.
Okay, so in the meantime, let me for a second resume all together, right? During this sprint, the group tried to create the instruments needed, the tools to come to a baseline measurement, right? And in the same time, we put the basis to improve the performance, as you see, at all levels, right? So, but a very big part was provide the drivers to the test guide to test properly all the software that we have. And of course, with the next releases, we will be able to, sprint, we will be able to apply and put all together with the test and the measurement.
Okay, as far as the test status, we agree with the team on the test methodology and also with Google. On the test script front, we created 4 test scripts to test performance. 2 on the latency, northbound and southbound. That means we measure intent install latency and any network topology event latency across a cluster of 1 to 7 nodes. On the throughput test, as Ali and some of the developers have talked about, it's utilizing some of the node providers and also a random installer to create loads on northbound and southbound, and then we take the metrics from within ONOS to determine the throughput of the system. Also, that each performance test will scale from 1 to 7 nodes. So each of our member, Cameron and Andrew, will talk about the latency and throughput tests. We planned for building a full 7-node bare metal cluster, and we were missing 4 nodes, and those servers parts didn't come in on time this week, so that was not done. But we do have 3 nodes that we did some preliminary profiling on. Last, we're going to touch a little bit about getting the J profiler ready, and some of the example profiling that we can talk about a little bit.
What is J profiler? Sorry.
J profiler is a Java profiler that's basically profile where the hotspots is,
So
how the threats being run.
it's a tool that allows you to instrument your JVM.
Right. So I thought we had that, right? We have been looking at that, right?
We have it. I mean, I've been using it. Developers have been using it. They haven't been using it. Okay.
So with that, we first go to latency, Andrew.
Yeah.
So with the additional resources and I guess manpower that we have, we got a lot of help from Kelvin, and Adi and John to basically revamp our entire code base with the F8 guidelines. Early on in this, in terms of the latency performance test, we were able to refactor the script to gather more data. So previously, we had the model on the bottom where we got information from all the nodes and kind of put it together to get a max or average. But in the improved format, we have the one on the top where we're gathering information from all the nodes and storing them in an array, so that we can later on analyze individual nodes in each iteration to get a more accurate and parsing of the data. And again, we have an improved result summary of the format, and it'll look something like this, where we have node summary, and for each node we can see the data. And this is an example of a switch add information, and you can see that as we scale out, we don't see a performance degradation. So the whole point is to get a more finer granularity of our tests.
Okay. And Cameron's going to talk about the throughput test scripts. So I'll bring up your.
So I'll just give a quick walkthrough here of kind of. So on the left here, we've got an intent event throughput test, and so let me scroll down here. What this is doing is testing our intent throughput. So we have this initialization case where everything gets started up, and we configure this null provider right here. And so in this case, we kind of flip back and forth with having the flicker settings on and off. So right here, we just make sure that's written and turned off. We start at the first node, and this test case 3 is actually where the testing is happening. So the process is we distribute 7 switches over however many nodes are being run. and just assign mastership evenly. This was a very short test case just for the sake of producing this file. And then we grab this intense event metric after we've started a load. So we just grab that metric, and right now it's parsing out the M1 stat. And then this process is simply repeated. You add another node, run the test again, reassign the switches, add another node, and once again reassign the switches. And so on the right here, there's a link event throughput test, and it follows a similar sort of process. We go through back to that null provider configuration file and set it so that the links are flickering. And so there's 7 switches, and we just turn the links on and off so that it creates a whole bunch of network events. And then we follow an almost identical process. And while those events are flickering, we measure the event throughput. And once again, scale to 2 nodes, and then kind of set everything up again, and then scale to 3. And then both of these tests will be, it'll be a very simple manner of transferring them over to bare metal servers since we have those set up so they can run on the full 7-node to conform with our 7-node test.
At last, I want to toss up a few examples on the JProfile, kind of segue to what we're going to do next spring. As Ali and Thomas all those alluded to, that the development, things are changing hourly, right? So don't read too much into the data on the profiler, but at least it provides a kind of a sneak peek of what we can tell from doing profiling. For example, this is a ONOS intent. I mean, I'm talking about this slide probably going to create more questions than answers that we have, because I haven't investigated a lot more into it. But at least what we can tell is that, for example, this is looking at all the ONOS intent threads, and we do the push test intent method, pushing concurrently probably 10 threads of batch intents. But what we're seeing here is that we're not seeing a lot of parallelism. Whatever that code commit is, that this one is probably about a day old, so I don't exactly know exactly what's being committed as far as the latest development. So we're not seeing threads are being concurrently run. So they're kind of staged, first of all. Secondly is that there are a lot of blocked process. So we need to dig deeper into why they're blocked and why there's enough parallelism in this profiling.
So tell me, I mean, I understand maybe we should not read too much into it, but are there multiple instances also starting intent push, or this is only one intent? This
is one instance of ONOS running on a bare metal server which has 40 cores, right? And the intent threads, Brian can talk more about it, is that there are, looks like there's concurrently 12 threads running, or 12 worker threads running, right? But we're not seeing the parallelism in terms of, you know, they're all running at the same time, right? They sort of stack.
So why you're seeing this is probably due to the way that I was talking about earlier, where we return these objects that the intent service has to pull and listen to, and basically it's just pulling, asking to get the information, waiting, pulling, waiting. That's why you see the thread. You don't see much green. What you want to see here is green.
Those are runnable.
I haven't understood the color scheme. So what does the color scheme?
The runs are runnable.
The color scheme is not runnable.
Oh.
So the reds are the threads that are being blocked. So
anyway.
And then another one I want to quick toss up onto. Actually, this one has quite a bit of more parallelism. This is actually. Oh, I'm sorry. This one is using the demo installer. This one is pushing 10 threads of push test intent method, and it seems like this one has a lot more concurrent running threads. But with that, you still don't see on the given time there's multiple runnable going on. Most of them are either one runnable, rest of them are being blocked, you know, whatever. I mean, those are kind of data we can dig into more as we go in the next sprint. Okay, right?
Good. I think this is Very helpful. But hopefully we will see more greens.
I mean, in the first picture that's even showed, I mean, one of the intentional design decisions and one of the sort of things we realized was a piece that was sort of unexpected to app developers is that we said from a single application, all of your intents will be serialized. So that means if you push intents from a single app, the maximum parallelism you're going to get is 1, regardless of how many cores or anything are in the system or intent installation. It's going to change. Which is going to change.
Yeah, okay, good.
There are 2 other things that aren't technically performance, but should probably be covered somewhere. One of the things we did last week was we had our first revision release for Avocet. It was 1.0.1. That was last Thursday or Friday. And the primary purpose of this release was to address our first security vulnerability reported by Charles Chan and with help from Jono and David Jorm. It was a bug that enabled people to send malformed packets to the controller and get NPEs, which killed threads. So that was the primary reason for the release. But we also used the release as an opportunity to fix a lot of other bugs and small deficiencies in the controller that have been discovered and reported by people since December. So thanks to people who both submitted and helped fix bugs. And the other thing that I wanted to mention was 1.0.0 was done, the release anyway was done completely manually. And we'd like to work to a model where these releases are automatically done. We're sort of a long way away from that. But we took a small by starting to automate some of the smaller pieces that are required to do the release. So hopefully we'll be able to build these things up and eventually get to a point where it's a single button push. But not yet.
We'll get there. All right.
Okay. Yeah, he told for
scale?
Yeah.
Yeah. Okay. So now we're going to transition to just get short updates from David. Right. And Mark, you were first in the list.
No, I'm not the presenter. Shubin is the presenter.
So I need to.
Who's going to be the presenter?
Oh, you want? Oh no, you can use one.
Yeah, so is this working?
You're not presenting.
Oh.
Just do show my screen.
Is it showing?
Yeah.
Yeah? Okay. So, yeah, so since last Monday when we did our, presented our planning, not all that much has been done. But here's a few things that have been completed. So we spent most of our time continuing to plan our proof of concept with several partners. Some bug fixes were done to make the ONOS, the packet optical application better suited for multi-instance. And Fahad has been working to bootstrap the mininet and Linkly integration. So priorities will be further planning for the proof of concept and importing or realizing true scale out for the IP optical app.
Do you have commitments for devices? Yeah.
Soft commitments.
Yeah. To get that hard.
Yeah. But it's looking good.
You know. Yeah. Okay. All right. It's a big accomplishment.
Well.
Thanks to the vendors, whoever is here.
Sure.
Okay.
Stop sharing.
Wait.
I'll change it back to you.
Show my screen. Yeah. Okay, let's talk briefly now about how it's going SDN IP and Internet 2. So I have bad news, good news. Let's start from the bad news, and then we get better. So the bad news is that we are stuck in the deployment because we have an incompatibility with a vendor that doesn't perform what we consider like a little bit basic, which is override the destination MAC address. And as you may understand, in a route, it's quite fundamental. So without that, we cannot go anywhere. But we are not totally stuck. Of course, we talk with the guys of Internet 2. We have another vendor. We had some ideas to deploy anyway SDN IP on the Internet 2 network, which is basically use the other vendor at the edges where we perform the destination MAC rewriting and using the vendor against OpenFlow just in the core, okay? So that's the idea. And of course, we ask to the vendor to support this feature in the future, okay? So this is the bad news, but once again, it's not so bad because we're moving forward. The good news is that all the big work that was done to try to install SDN IP and ONOS on the test lab provided by Internet 2 let us resolve lots of issues, both on the ONOS side. So lots of bug fix, for example, that Brian was talking about before came from this deployment, right? Because we know we can do whatever we want inside here, but then when you go outside in real life, that come out lots of other issues. And so that was good. And we did lots of experience with that. And we are also compatible now with the Internet 2 flow space firewall, which is good. So the good news is that everything is deployed on our side. We are just waiting basically for them to swap the switches and go with the other vendor and test it again. But potentially we solved all the bugs till the end. So the last step didn't work, right? But in theory...
Sorry, I missed something. What is the last step?
So the first step for me, for example, was, that is not so trivial as it could seem, is connect the switch to the controller, do the handshake. That was one of the biggest problems. It seems stupid, but it was.
It wasn't the switch you were controlling, it was a flow space firewall.
Yeah. I mean, connect the data plane to the control plane anyway, right? Connect the flow space firewall to us. So, and then topology discover, ART, other things. We fixed everything. We arrived till the last step, which is really install the intents that are used to...
The rewriting came in.
Yeah, and once we have that, the flows can be installed and we can move forward, right? So we're at a good point on our side at least, okay? So in the meantime, we moved forward in general with SDN IP, and we did an investigation on the ONOS behavior. Maybe Pimpin can talk more about this, and I can share later on the document with the results with you. So basically, this is also a requirement that came from Internet 2, right? They said, okay, well, I don't pretend to have something that is production-like, but you need to tell me at least what should I expect from your software, right? So, for example, right now there's not a nice mechanism to reconfigure at runtime SDN IP. Basically, if you want to add, for example, another BGP peer, you need to restart everything from scratch. So, is there, for example, a trick to me to reconfigure everything, change manually, also if it's terribly uncomfortable and error-prone, but reconfigure manually SDN IP, restart everything? And what should I expect from that? The flows will remain there. ONOS will destroy all the flows. So what happens if I reboot the controller? If the controller crash, my traffic still remain in the data plane or not? So we did all this kind of investigation. We came out with a written document on it, and we have all these answers. Some of them are good, some of them are not, but we'll get better. Sorry. Integration. So next part was always done by Pimping on integration tests. Okay, so we cover all the single instance integration tests are automatically executed every night. We have 6 switches, 100 peers, and 1,000 routes exchanged. Okay, and so are both on master and 1.0, and so we can see what goes good and not. Okay, that's it. Thank you.
Okay. Thank you. Alvin?
On my where?
On the slide section. Should we give Mark's presentation?
Mark's, yes. Yes. Where do you want to go?
Okay, IPv6.
I have like,
This one?
I have it open.
Mm-hmm.
Alvin, maybe you want to talk close to the phone? Okay, good morning, everyone. This is more like presentation of what IPv6 status is in ONOS. It is kind of unusual because so IPv6 development is kind of unusual for us so far because it started not because it was in the plan. It started because there was external interest, and there were folks outside of ON.Lab who said, "Okay, what can we do about IPv6?" And we said, "Okay, we'll help you, and you can do the work." And so, primarily 2 folks, Charles Chan from Taiwan and Hiro Ishiguro, they have been the primary external folks who have been doing majority of the work. And because it is kind of best effort, there is no formal Scrum meetings and there is no explicit. So basically, it is best effort. When they feel it, they want to do something, then they do it, and then we move on. So there is no formal Scrum process. And so far, well, this and the past sprints we have, well, they have done the basic pieces like support for IPv6 related classes. Some of their internals, like the neighbor discovery, has been done already. There's still some work remaining for the IPv6 selectors, and basically the IPv6 match and actions is work in progress. And we also have the BGP and IP support. But those pieces are more like in isolation. They have not been integrated yet together. So this is what we want to do next. We want to finish the IPv6 match and action support. To also finish the post monitoring, which is also needed for Asian IP, and also to start doing integration tests. And ultimately the target for the ONOS 1.1 release is to be experimental feature, to have basic IPv6 intent support, the host service to be there, SDN IP to install IPv6 routes, and so far it is just unit tests, no QA testing. So this is why it is experimental feature. And eventually the one after that, ONOS 1.2, it can be tested and supported.
Maybe I just want to be sure. So by doing all of this, 2 IPv6 hosts will be able to communicate. Or I mean, flow set up by IPv6. I mean, ONOS and do that, right?
In the context of 2 parts, just host, yes, you could put IPv6 intent. Also, in the context of Asian IP, you could have 2 external IPv6 domains. They can communicate.
Okay, so that at least in an experimental way that would be done and demonstratable end of the for 1.1 or
so for 1.1 this is where we would like to be.
Okay.
Again, not much testing and no official support, but because the remaining parts are not that large.
Very good. So you think without
things move more faster? Well, yes, with external help. I meant to say with external help it helps faster, but sometimes not getting down into the full parity also helps. You just have to be agile.
Yeah. But in terms of the control plane, is there any work that needs to be done additionally, or control plane running IPv6? Say a controller and the switch.
Oh, on the controller? No, this is all in the context of intent and associated. So you're still using IPv4 between the controller and the switch. This can be addressed later when people say we want. So this is one of those things. There's some pieces there. There's still some remaining work.
May I share my screen? Okay, so what do we aim for? Actually, this is kind of sprint 3 and previous sprints since the release. Basically, we threw the topology view together fairly quickly in the run-up to December, and the main JavaScript file is 3,100 lines long, which is not very modular, and it's not very maintainable, and so on. So the goal for this release is basically to re-architect the GUI code base so that it is modular, so that it can be unit tested, so that it is extensible, and so on. So we chose to go with AngularJS, which is a JavaScript framework that is supported by Google, comes from Google. So there was a lot of learning about that. We also wanted to rework the topology view, basically to bring it back up to what we have currently. We also wanted to push a little further forward, so we've implemented a new device list view, which I'll show you in a little bit, and there's also cleaning up some technical debt. So what did we actually achieve? The AngularJS framework is now in place. Because the new UI work is still work in progress, we've actually got it coexisting with the current GUI. There was a lot of work basically rewriting framework pieces as modules. I'm not going to read them out here, but you can see that we've broken things down into big buckets of utilities, scalable vector graphics, layering, remote services, and so on. The topology view, we re-implemented the loading of the background map with zoomable behavior, the WebSocket connection to the server, and initial panels, the summary pane and the instances pane. We've added a new device list view. Oh, and we've also implemented the switching between dark and light themes. The device list view includes a scrollable table widget. And then another improvement from last time was we've now written a little mock server in JavaScript. Before, to help the developing, we had test code or test harness actually within the production code. We've now removed that. So the actual production code, it can now be pointed to either the real ONOS server or to a little test mock server that you can basically, from a command line interface, single step through events so that it helps for the actual development. What did we miss from our original list? I didn't actually get as far as re-implementing, showing the devices, links, and hosts, and so on. There was just so much work to do. So where are we going from here? Basically, the next sprint will be focusing on completing the topology view, get it back to where the current GUI is. and that will include some of the framework modules such as this quick help panel and so on. So that's the slideware. What I'd like to do is just show you a little demonstration here. So I have ONOS, a single instance of ONOS running with Mininet backend, and we're going to just start up the GUI. So this is the old GUI, the one that we all know and love, and coexisting with it is the work that we're doing for the new framework. So by just adjusting the URL slightly, we can load. So this is actually the new one under Angular and the modularity and so on. What I wanted to show you here is the little mock server. So this is just running a little CLI. And so what we can do is actually, if I quit this and I just do a quick. Is that readable? What I'm basically showing is there's a directory where we can create scenarios, and in these scenario directories we have basically hand-coded event files. And so by running the scenario, and then by changing the port number that the view is going to, so in this case I want to go to WebSocket port 8123, we're now talking to the little mock server, and now I can send events step through one at a time through the scenario. So the first event that gets sent is a show summary, and so now you can see in the at the bottom there, I received the event, and I can see visually that the UI did the thing that it needed to. So the next event is going to be a add ONOS instance, and you'll see that the GUI reacts by adding the graphic visualization of that. So this tool is very useful in helping to develop the UI or recode the UI. What else did I want to show you? So,
and will this help a developer who wants to insert a module into our UI?
Yes, we could also make it part of the software development kit and say, you can use this tool if you want to use the WebSocket technology for your specific view. Then you can create your own events and use that to step through. We've now been working on the themable aspect of this too, so the new views or the new work that we're doing is themes between dark and light. We're also, this current navigation is just a temporary placeholder. We haven't spent any time on it really, but just to show you that there will be a way of navigating to a new view. And so now this view here, it's talking to the ONOS instance, which has the ATT topology, and we've got a scrollable table of the devices. This was some stellar work done by Bree. Thank you, Bree. And I just wanted to show you again that this is also themable. And also the scrollable table we've packaged as a modular widget. And so if I were to just show you the code to implement that view, this is the HTML, which basically gives the structure of the table with the columns and what a row will look like, and then the corresponding JavaScript is basically 10 lines of code because it's using the library that we've given. So these two files are essentially what creates this view. That's it.
Thank you. So you, or is Ali going to talk about?
Yeah, for sure, Ali mostly, but I just give the thing on.
Okay.
What? Oh yeah, I don't need. slides for this.
Oh.
So, Corsa. So just a quick update on Corsa. Ali and John are the people, with other guys anyway, are the people that are mostly working on this from the development point of view. I just want to tell you that on kind of deployment side, we have the opportunity to be connected with a Corsa switch. So right now there's a VPN between us, and there's a switch on their side, ONOS on our side, and we can access to the switch. And the switch is currently connected to ONOS. The good news is that the handshake went just fine. We didn't have any problems, surprisingly.
One step was easy.
So, but this was the first step. So they're going to talk about the difficult steps.
No real difficult steps. So, with the help of Sangho and Srikant, we've built a group service in ONOS that allows us to provision groups down onto the data plane. We've also added some support for simple multi-tables. So the idea here is rather than exposing the pipeline into the core, we give hints about what kind of tables there are, and the flow gets tagged with like, I'm a special flow, and I want to be treated in this way and be placed in this type of table. So we've kind of promoted the idea of table types rather than table pipeline. That's kind of what's been done so far. Other than that, there's still more to do, but it's all kind of not a huge deal. We have a set of flows that have to be placed in the static table that the pipeline that the Corsa switch has. The Corsa switch has a bunch of the pipeline, and that pipeline has a bunch of static tables, and we know the rules that we need to populate. We just need to write a driver that populates those tables. Not a big deal. And did I miss anything?
But sir, tell me something, sir. How dependent is it only to Corsa thing? It's great that we are able to work with multi-tables and all of that, so that is all good stuff, right?
So the multi-table part I was talking about is not dependent on Corsa.
Is that?
No,
it's not.
No. The part that the driver for the Corsa switch is 100% dependent on the Corsa switch. Right? I mean, the Corsa, well, not even 100% dependent on that Corsa pipeline.
Yes.
Right.
And so what fraction is that driver and, sorry?
It's tiny. It's part of the open flow subsystem, which allows you to load drivers for specific types of devices. So if you look at, well, basically all the types of switches we know, right? Yeah, exactly, have a specific driver that allows them to do whatever is specific to them. Some of them have to break up rules and place them in different places, or we have to slightly tweak the rule a little bit. So that's where like quite specific things happen.
And so Corsa has exposed us enough so that we can write that, or they are writing it, so how is this working?
So no, they've given us the pipeline.
The abstract description? Some API?
A pretty specific description of the pipeline.
Okay.
I haven't checked whether we could negotiate the pipeline with them, but it's not necessary at this point. I don't think for explicit TCP stuff, but so they've told us what the pipeline is, and they've told us what rules go in the static table, so we just populate those.
Okay.
That's it. That's really that's all that's required. It's a kind of a simple-ish pipeline. There'll be more problems when we have kind of like a pipeline, generic pipeline environment. That's further down the road. We'll figure that out when it comes down to us. Okay. Anything else? I'm missing something? That's it.
Okay, thanks. Next one I'm especially excited about because finally getting SRI with some funding and working with us now. So Phil and Martin and sure. And is that secure to connect?
Not mine.
All right.
There's the keynote. ONOS Security Lite.
This one?
Yep.
Not on the agenda.
Okay. Like too large. Okay. Good morning. I'm Tanghun, and I'm a grad student from KAIST, and he's my advisor, Prof. Jungwon Shin, and we're currently working with Mr. Felix Porras and Mr. Martin Fong from SRI International, and I'm here to talk about our proposal to add a security feature that could possibly add it to the next ONOS Cardinal release. And it's going to be it's called Conservative Mode ONOS, and it's going to be an optional feature that could enhance the robustness of the ONOS.
Do you want to call it either security mode ONOS or robust mode ONOS or conservative mode ONOS? Conservative has such a negative connotation. So,
yeah. So we didn't just sound like.
Yeah, go ahead.
We just want to scare people.
No, but I think that is not the political spectrum, but in general something to think about.
Do you like it?
No, I like it more either the secure mode or the
okay.
The robust mode. Okay.
All right. So, slide. Okay. So I've been playing with ONOS since it was first released, and I found those APIs very useful, well defined, and also very powerful. And I was a bit concerned about this because if there's like mission critical applications running on ONOS, there's a possibility an application can remove hosts or devices to modify the ONOS network view, and it's gonna be affected. So consider the case like on the figure on the right, and say there are like two applications deployed, and say one application, at the application one somehow accesses southbound API and generates device disconnected events for like switch one. And after that, if an application two tries to install an intent to establish a connection between host A and B, and it's gonna fail because there's going to be no valid path available between host A and B. So we're a bit worried about this. So, and for those who are running mission critical applications and want to avoid such circumstances, we thought about this conservative mode ONOS. So the objectives, they are to offer new option for granting the true minimum required capability to ONOS applications, and also to let the network operators know what each ONOS application is capable of before the actual deployment. So to make that happen, we're going to apply this permission model. Looks like this. It consists of three access control mechanisms, and the first one, bundle level role-based access control. It just makes sure ONOS applications only be able to access northbound APIs and other necessary utilities. And second mechanism would be application level role-based access control, which is going to allow like which going to enforce non-administrative ONOS applications to not access admin services. And third one would be much more fine-grained. It's API level permission-based access control it's going to only allow ONOS application to call a certain API if it has a permission to do so. So that was a permission model that we're planning to apply to ONOS. So we're thinking about using a policy file that looks like this, and it's going to have information like if a bundle is an ONOS application or like other bundles like provider services, and also it's going to have, if it's an ONOS application, it's going to have a role if it's an admin or non-admin, so that an application with an admin role can access the admin services, and if it's not, and it's not going to be allowed to access admin services. And there's also going to be a list of permissions to be granted to ONOS app bundle, and that's going to be something like logical representations of network operations. And with having that, that file is going to be checked upon the installation of application every time like ONOS try to deploy it to itself. So, and another benefit that is possible from this is that we can let like network administrators to know like what kind of permissions they have, like what its behavior is going to be like. So we think this is going to be really helpful to enhance the robustness of ONOS. So this is all I have, and thank you.
Good stuff, excellent stuff. Now only thing is, when does it get done? No, this is excellent. I'm so glad that you're able to take it on.
Well, in order to working through their year out, we're collaborating continually. I guess we have to talk to you guys, but as we go through, think through the development, talk to you guys as well. How and when that fits into your schedule, which is a key question. And if this fits into your schedule, what sorts of feedback we get from you as we try to put that together.
If you're developing on a feature
branch.
branch.
Can we repeat the comments or set into the mic and speak line and content?
Well, there was but the bottom line of what was essentially said is, on that now, hope to talk to you more about how that might fit into the schedule of planning that you guys are all working on.
Yeah. Excellent, I think.
Okay.
Good.
Can I have 5 minutes on the test improvement?
Yes, please. I'm sorry.
I don't know if
I had a question on the for 50% of clients on the entire cluster or for each one?
Actually, I've seen you guys. I don't know. Right. It depends on how it's going to be implemented.
So one of the things that we sort of laid the groundwork for is if we have a more formal notion of an application. When an application is introduced, the bundle is introduced to the system, then ONOS would parse that config file and actually build its in-memory representation, and also distribute the bits of the application. Sorry? No.
Policies will apply on all nodes.
So the application will be introduced on one node. That application policy file will go into the in-memory representation that ONOS maintains. The application as well as its metadata will be transmitted to all other instances in the cluster. And that way, same bits and the same view of the permissions and the same metadata for that application. And if it's updated in one place, it'll be reflected across the cluster.
Okay, one more presentation. Go for it, John.
Okay, I'll try to be quick. So, for our testing structure, we decided to mirror the branching structure of ONOS. So, ONOS has a ONOS 1.0 branch, and we'll have a ONOS 1.0 branch and test on with our tests snapshotted at that point. So that way, as maintenance releases come out, we can easily revert back to that, and we don't have to worry about new features. If there's a feature branch that needs testing, then we'll
create that, but I think generally probably won't do that unless it's needed. We now have Jenkins jobs that will run, it will nightly poll the maintenance branch, and if there's a new commit, then it will run and automatically post to the wiki, and that will run side by side with the current Jenkins jobs that run on the master branch. We utilize some of the Mininet code check utilities to test our code. It is also Python. And we have fixed a lot of code style issues. We've refactored the Mininet driver and the ONOS driver a bit. The Mininet driver, we now have the ability to stop and start networks within our test, so we can load a different topology mid-test if we need to. There's some refactoring of the HA tests, and there's some new test cases added to the functionality test. They're not yet in production, but the scripting is complete. They just need a little bit more testing and then commit to the repository. And with the new changes to the Mininet driver, the Cho test will now load different topologies during the test. So we can test the packet optical and other things. And then here's a quick update on some bugs. So there are 76 bugs filed since our release. Of those, 15 are in resolve state, so they're fixed but need to be tested, and 28 are closed, which means they've fixed and been tested. And there's a total of 50 bugs in Jira that are open or in progress, including bugs filed before the release. And then we're working on scripting some regression tests based off these bugs add to our testing.
Okay, thank you. Anybody else? Anything that they want to talk about? Any questions from online?